All right, guys, let's look at the third student task statement for lesson 14 called Buying and Selling Power. It says a utility company charges 12 cents per kilowatt hour for energy a customer uses. They give a credit of 2.5 cents for every kilowatt hour of energy a customer with a solar panel generates that they don't use themselves. A customer has a charge of $82.04 and a credit of negative $4.10 on this month's bill. They said, what is the amount due this month? Okay, so let's do some quick annotations. So they said the customer has a charge of $82.04. Okay, so I'm underlining that. And they said they were given a credit of $4.10. All right, so what you want to do is you want to add these two numbers together to find out, well, what's the amount that's due for the month. Now, just what was discussed in previous lessons, adding two numbers with different signs is the same as subtracting. So I want to do $82.04 plus negative $4.10. Okay? So, well, I could ignore the addition sign or whatever. Let me take that away because I do want to subtract. Sorry about that. All right, so I could drop 4, bring that down. I could borrow, this is going to be 9. And 81 minus 4 is $77. Okay? So needless to say, since $82.04 has the greatest absolute value, that means our answer would be positive. And this is how much is owed for the month, or how much is due for the month. So $77.94. All right. For the second question, it says, how many kilowatt hours did they use? So what I want to do is I want to not focus on the $77.94, but I want to focus on how much was charged total. And I want to divide it by the unit rate that's given in the first sentence of this real world situation. Okay. Why not the second unit rate, which is the 2.5 cents for every kilowatt per hour, is because that's when for the solar panel. And right now we just want to figure out how many kilowatts they use total without the credit. So I'm going to divide $82.04 divided by 12 cents. Okay. Now, when I divide with decimals, I want to focus on getting rid of that decimal for the dividend that's on the outside. So moving it over, sliding over it twice. 2. And now, or the divisor. I'm sorry about that, guys. And now I can start dividing, okay? So how many times can 12 go into 82 without going over? And that answer is 6 times. Which 12 times 6 is 72. And that's pretty close to 82. So the goal is to find a multiple that's close to the number that we see but doesn't go over it. So 72, I'm going to subtract. And I should get 10 left over. All right. So now that I have 100, well, how close can we get 12 to 100 without going over? And that's 8 times. Because 12 times 8 will be 96. And then how many times can we get 12? How close can we get 12 to 44 without going over? And we could get that 3 times because that would be 36. All right, what's left over is 6. Now, we could leave it as a fraction. We could not. We could turn it into a decimal. At this point, we can't. If we wanted to turn it into a decimal, all we have to do is add a 0. And it's going to keep going. So let's see. Add the 0, 80. It's going to be 6 times 72, 8, and look at that. It's going to keep going and going. So our answer, we could actually round it to the nearest ones place. So we could say how many kilowatts did they use. We could put about, because it's not the exact answer, about 684 kilowatt hours. Okay. Now let's move on to the next one. It says how many kilowatt hours did they generate that they didn't use themselves? Okay, so what I want to do is I now want to take the $4, negative $4.10, and divide it by the second unit rate. And the same applies. I want to move that decimal over until it's no longer, there. So I no longer has numbers behind it. So 1, 2, 3. Now at this point, I would just add a 0. Okay. So now if I had to rewrite it so you guys could understand it better, it would be 25 and 4,100. So 25 could go into 41 times, 41 one time. Okay. And then, and I'm going to say this, I'm going to interrupt myself, my thought process. Anytime I divide by 25, I always think about quarters. Okay, because that's something that I'm most familiar with. I always tell my students, hey, when you divide by 25, think about quarters. Think about money. So that just help develop fluency when dividing by 25 or even multiplying by 25. So how many times can 25 go into 160? Well, 160 is close to 150, and 25 could go into 156 times. And then you ask yourself, well, how many times can 25 go into 100? Well, there's 4 quarters in $1, so 25 can go into 100 4 times. And this one was a little bit more friendly. There's no remainders left, so how many kilowatt hours did they generate that they didn't use? 164. And we want to put it in the context of the situation. Kilowatts hours. Okay, so if you guys didn't understand this student task statement or just this lesson in whole, make sure you guys refer to your manager's Google Meet session, and I'll see you guys in tomorrow's lesson.